P of A plus P of A prime is equal to P of A plus P of A prime.
Hold on.
What?
I wrote it down.
Right.
Yeah.
100%, whatever out of whatever, kind of thing, same fraction on top as the bottom. We can rewrite this as well. Another way we use this is to say, oh, I want to find P prime, P of A prime. P of A prime, if I want to find that, well, I can use 1 and subtract off P of A. I can find P of A prime. Or vice versa, P of A, right, would equal 1 minus P of A prime. We can solve those formulas and find that. But all three of those are equivalent statements, say the same thing. So, yeah, that's.
Is that a way of checking it? Is that like, I don't understand why. I mean, I understand why you're basically saying like 2 halves make a whole, kind of.
Yes, that's what it is.
But why do we need to know? I mean, I know why we need to know that, but is that a way that we can check stuff? Why are you showing us that?
Yes, and we
'Cause
will
feels
need
like
it. We will need it.
trigger.
I think last time I talked about, we will be using GeoGebra, the probability of getting a certain outcome or less. And what GeoGebra will give us essentially is the area under the curve on one side. But if I then ask the other question, I might have to use this complement idea. Because the full space, I don't have different color marker or chalk, but this whole space combined underneath this curve is 1. It's a probability thing. We'll talk about why later. But this space, this area under the curve plus this area equals 1, and I can calculate the above area just as easily as if I can calculate the below area. But if I can calculate the below area, I can calculate the above area with this probability of complement idea. So,
That's a tongue twister.
yes, thank you.
Lots of P's and
That
D's.
sounds like Pythagorean.
Yeah, yeah. All right. So this is theory. This is where statistics meets theory and math theory combined. So, and we'll talk about it when we get there. But so this does come up probably more than we'll probably use this complement idea and those formulas more than anything else we're talking about in this chapter
This
later on. Yeah, those 3 formulas. All right. So last one. So I want to calculate the probability of A given B and the probability of B given A. And we're asking, are the probabilities the same? So, so there's kind of 2 ways to calculate it. I'll go over both here because we did talk about this last time too. There is a formula that we talked about last time to get the probability of A given B or B given A. Probability of A given B. You remember this formula?
Well, yeah. Because the B is our new sample set, right?
B is our new sample. So that's the thinking way of going over. There was a strict formula we
Oh, I
could
don't
use
know.
too.
Hold on, let me look.
So probability, I'll make it a little
Oh, is
bigger
it
for
that-
some reason.
A or N, B.
A and B, yeah, A and B. Probability over the probability of
B and A.
B. Good,
B of
just
A.
B. Just B, right? This looks like a denominator in this little thing right here, right? So B is gonna go in the denominator. That's how I remember.
Okay.
That has to be B down there because B looks like it's in the denominator here.
Oh, yeah. Okay. Yeah, that's right.
So that's how I remember. It doesn't matter. I can flip-flop this. If I flip-flop this, P of B given A, then same thing on the top, A and B. It doesn't matter order-wise what A and B are, but I would divide by what if that was.
A. P of A.
Okay, so the formula changes a little, but just recognize, right, what goes on the bottom. It's all right. Right? These are right. We got the cheat sheet. So these are the things you want to put on the cheat sheet for next time. Okay. All right. So we can use the formula.
No formula.
Yeah, and then I'll talk about too with the how do we do it by thinking about it. Actually, let me show you thinking about it, and then I'll do the formula because Once we see the way to think about it, then it's harder to see. So we are given, with probability of A given B, we are given B. B already occurred. B happened, so, but we don't know exactly what B we got. So B happened. B happened, that means we're somewhere in here, right? So somebody secretly knows some extra information about one of these things that happened. So they say, psst, by the way, it's in B. It's like a little leg up on the probability of that thing. It's in B, right? That thing. So I know it can't be anything not in B instead of those ones. So it changes our sample space in effect. Our sample space becomes B. We're no longer considering all this stuff anymore, particularly no longer considering that orange stuff there. That orange stuff is gone because it's not in B. So if we're given this stuff, how many things from A do I have in this B? A and B. I have all of these there. I got 2, 2, 4, 3, 1, 3, 3. I have 4 things out of how many B's?
8.
So out of B's, yeah. So we had 8 things in there. Yeah. So 4 out of 8, or 1/2, we could say, is our probability of A given B. Let me show the formula will work. So the formula says take the probability of A and B and divide by the probability of B. So probability of A and B, I think we calculated it somewhere, right? Oh, there it is. 4 out of 12 is the probability of A and B. The probability of B, I think we calculated it somewhere.
Yeah, we did.
There it is. 8 out of 12. When we do this division, thought I was going to get through the whole thing. Sorry, I didn't understand that. I'll have to explain it again, Siri. All right, so what happens to those denominators when I keep, change, flip, and do my mathematics? Yeah. And we are left with 4 out of 8, just like we got in the top one. So sometimes we can think about it and think about our spaces and how it changed our spaces, but if we're lost, think about the formula. So that will always have to do those. And I talked about keep, change, flip last time, I think, when we flip that denominator, and those denominators cancel because they're the same. This is an example of why I don't want to simplify and make that 1/2, because then they wouldn't cancel as well. And it would be harder to cancel those. So I think it would work here anyways, because those are nice numbers. So, all right. Last one. Probability of B given A. So let's go through that step again. You can use the formula if you're confused about what I'm saying. So I'm given A happened. Psst, by the way, my ordered pair is from A. How many B's do I have in this group? Yeah, 1, 2, 3, there they are. They're underlined even. I have 4 out of 6 possibilities. We can check it with the formula, but it works. So P of B given A is 4 out of 6. Are those two numbers equal? No. They are not. This is 2/3. This is 1/2. They're not equal. They're just pointing out that these things aren't the same. They're typically never the same. So notice A is kind of being divided by here.